Hi everyone, this is our section 1.4 outro video. From now on, whenever I make these YouTube videos, any statements that are written with this blue typeset and the results below them, I want you to write them down. So for example, in section 1.4, you have these reciprocal identity equations here for your trigonometric functions. And you also have these equations here for both tangent and cotangent defined in terms of sine and cosine. Also, we talked about this in Tuesday's lecture, the domain and range, or rather the ranges of your trigonometric functions. So you're going to want to write these things down before our lecture today. This part of the section I did not get to on Tuesday. You definitely want to write this down. These are your Pythagorean identities. These will be derived for you at a later time, or rather, the very first one, I'm going to point at it here, this will be derived for you at a later time. So for all angles theta for which the function values are defined, the following identities are true. Sine squared of theta plus cosine squared of theta is equal to 1. With that identity, you are able to derive the next two identities that are written below it. So if you take a look at this proof here, this is a proof showing you how you can go from this identity on the very top to this identity in the middle. So the way that you can go from one identity to the next is as follows. If you take the top identity and you divide both sides by cosine squared, your right-hand side, 1 over cosine squared is secant squared. That left-hand side, if I take a look at this line here, the numerator is a sum. We may rewrite this as a sum of fractions with the same denominator. Sine squared of theta over cosine squared of theta is tangent squared of theta. Cosine squared over cosine squared is 1. On Tuesday, we worked on this problem here, where you had to find all 6 trigonometric functions evaluated at theta, and you're given some information about where is theta, right? Let's take a look at another one of these problems. You're given tangent of theta equals square root of 3, and theta is in quadrant 3. So if your angle's in quadrant 3, we know the x value and the y value of that point will have to be negative. So for the triangle that's drawn there, let me draw it again in purple. Now, which two sides of this triangle do I know? Well, I know that tangent is y over x, right? But you'll notice here that you're just told that tangent of theta equals the square root of 3, right? I'm going to do something very sneaky. I'm going to write this over 1. Now remember, since theta is in quadrant 3, both the y and the x have to be negative. So this side is negative root 3, this side is negative 1. As you can see, their ratio, negative root 3 over negative 1, is going to give you positive square root of 3. We will find this r here using the Pythagorean theorem. Solving for r here, you should end up with r equals 2. Now that you have all 3 sides of this triangle, you can find the trig functions evaluated at theta. So sine of theta, this is going to be y over r. Cosine theta is going to be x over r. Tangent of theta is the square root of 3. From here, we can find our reciprocal functions. So cosecant of theta is equal to negative 2 over root 3. Secant of theta is equal to negative 2. And cotangent of theta is equal to 1 over root 3. Now, bear in mind that in these problems, it asks you to actually rationalize the denominator. Square root of 3 times square root of 3 is 3. So what does it mean to rationalize the denominator? This means to rewrite the fraction so that you have no radicals on the bottom. And then from here, I will just circle my results. Now let's take a look at one problem where we actually make use of those trigonometric identities in the blue. You are asked here to use trigonometric identities to solve the following. You need to find just sine of theta, given that cosine of theta is equal to 4 over 5, and theta is in quadrant 4. So we know theta is in quadrant 4. And it says specifically to use trigonometric identities. The identity that relates sine and cosine of theta is the following. Sine squared of theta plus cosine squared of theta equals 1. Let's plug in the givens. So I don't know what sine squared is. I have cosine of theta equals 4 over 5, so cosine squared will be 4 over 5 squared. From here, I will isolate that sine squared. One minus 16 over 25, so using your fraction rules, you would end up basically with 9 over 25 after simplifying. From here, I'm going to solve for sine by taking a square root. You're going to want to remember this fact here. If you take a root, it doesn't matter what kind of root it is, cube root, fourth root, what have you. If you take a root of a quotient, this is equal to a quotient of roots. The square root of 9 is 3. The square root of 25 is 5. We have a problem, though. Sine of theta is a variable. I'm taking the square root of a variable, so I have a plus or minus here. There's two roots. I cannot have both of these answers, though. I can only have one of them. Which one do I choose? Okay, you're told that theta is in quadrant 4. If theta is in quadrant 4, and I drew it for you here, if we look at that point, what do we know about that point? That point is in the fourth quadrant. So the x value is positive, the y value is negative. Since sine of theta is defined to be y over r, your sine will be negative. So we need to take the negative root. And now we are done with this problem. Alrighty, everyone. That's going to wrap up this lecture video. I will see you in class today where we will be starting chapter 2.